All right, I hope everyone's doing well. I wanted to talk in this video about research articles, how to read them, and also how to make sure that you're including the right kind of research paper for your semester project. Remember, for your semester project, your group will highlight and emphasize 4 research papers. All right, they have to be empirical based research, peer-reviewed papers. So let's make sure that we're finding the right kind of papers. There are secondary sources. Those are literature reviews. Those are papers that describe and summarize literature from several sources and present that information. You're looking for primary sources. You're looking for papers that describe the results of an experiment, and they have to be in a peer-reviewed paper, peer-reviewed journal. What's peer reviewed? That means me as the author, I send my paper to the editor, and the editor sends it out to peers, other colleagues that do similar type of research. They review the paper and then send comments back to me, and I revise the paper based on that, on those comments. And ultimately the paper hopefully is accepted. Right, so it's sort of a rigorous process to get the work published in a peer-reviewed journal. So that's what you're looking for. Now, how do you know you've got a peer-reviewed, empirically based primary source? Well, there's a few different ways. One is there should not be any colorful ads. The writing is very technical, not necessarily written to flow like a article in a journal like Runner's World or Triathlete Magazine or Sports Illustrated, where trying to grab your attention and present information more anecdotally. In peer-reviewed papers, they're very specific information that is provided to the reader so the reader can replicate an experiment if so needed. So I'm working on a project now on bike vibration. I was looking for some peer-reviewed papers to include in my understanding of analyzing some data. And I thought I would put together a quick video describing how to make sure it's a peer-reviewed publication and it's empirical based primary source. So I found this paper. I haven't read it entirely yet, but I'm going to show you how I go about looking to see whether or not I should read the entire thing and include it in the work that I'm doing. So first, this is original research, and it says it right there in the paper. So original research means it's a research paper, and this was published in 2019. Here's the journal here, Frontiers in Physiology. And I'm familiar with the journal. In fact, I can go and look at the journal page, and this is a good way to make sure that it's a peer-reviewed paper. You can look for information for authors, and this will describe the process of submitting a paper. And you can look at the different articles presented here, and you can see that these are not advertisements or what have you. They're just data collected by authors, and the authors are sharing those data with the science community. All right, so I'm in a peer-reviewed journal, and there's an impact factor. What that means, the higher this number, means that more people in essence read the articles in this journal. An impact factor of 3.3 is actually pretty high for our area. And so if you see that number, just know that the higher that number, even it doesn't have to go that high. 4 is high. In the science world, maybe over 10 would be a high number. But a lot of times our impact factors for our specialty areas are between 1 and 3. So this is a strong journal. It means lots of people are reading the articles that are published. All right, so I found this one, and obviously the title, the authors. I'm going to skip over the abstract because the tendency is to try to pull out a lot of information from the abstract, which is fine because you want to make a decision whether or not you're going to read the whole paper. Now, this is not that long. It's 9 pages in total, including references, so it's not that bad. But at the same time, I like to be efficient and make sure I'm zeroing in on papers that I know are going to help me. So the title seems interesting. I'm doing work on vibrations measured during cycling. So I'm going to skip the abstract, how I look at that. I'm going to go down the introduction. The introduction provides background information for the reader, but I'm really going down to the last section of the introduction, and I'm going to find the purpose statement right here. All right, I'm going to highlight that. Therefore, the aim or the purpose of the present study was to monitor the physiological responses, cardiorespiratory and metabolic, and the perceived effort, so RPE, related to adding vibration to cycling exercise compared to a standard cycle ergometer during maximal incremental exercise tests, or GXT, with similar power outputs and pedaling frequencies. All right, so this is interesting to me. And now, without even reading the rest of the introduction, I can get a sense of what the experiment is going to be. It's going to be cycling with and without vibration, and then it's going to be measurements of cardiorespiratory and metabolic measures. So VO2, heart rate, things like that, as well as RPE, okay? So right away, this seems pretty interesting to me. I'm going to keep reading. All right, now, what I'm going to do is, again, I'm trying to decide whether I want to go through the whole manuscript. It's important to know that if I include this citation in my project or in any of my papers, I need to have read the entire paper. I can't just read sections of the paper. But this is a way to start trying to tease out whether or not you're going to really zero in and read the paper in depth. The next section describes the experiment, but I'm actually going to skip over that because that purpose statement tells me what the experiment should be. It's 2 graded exercise tests, one with vibration and one without vibration. I am curious as to how they're delivering the vibration, but that's a detail right now. And then they're going to measure VO2, heart rate, most likely, and then RPE. So, and then they're going to compare those parameters between the 2 conditions, okay? So that's what the experiment should be. Again, I haven't read this, but that's what this is all going to describe is here's maximum graded exercise cycling test with and without vibration, which is exactly from the purpose statement. Cardiorespiratory responses, heart rate, which we expected, oxygen uptake, VO2, which you expected, VCO2, that makes sense too, and ventilation. So air, inspired and expired. And then RER, which is the ratio of VCO2 and VO2. All good parameters, RPE. Again, this is very predictable. I have not read the paper. I don't know the authors. I don't think I do. Let me double check. I do not know any of those authors. It's in China and Qatar. Okay, so no, I don't know the authors in this case. Okay, so the measurements are there. There's some pictures of the setup. Again, I'm not going to focus on this yet. I may want to come back and do that if I'm going to invest some time. This is just a schematic of the protocol. Here's the stat analysis, which I'm going to look at later on. I'm not even going to look at the results yet. I'm going to go all the way down to the first paragraph of the discussion. And almost all papers will write their most important observation in this first paragraph of the discussion section. They repeat the aim of the study, which is unnecessary. We were expecting, this is their hypothesis. However, here's their main observation. The main outcome showed that vibration cycling physiological responses did not differ to normal cycling, with the exception of significantly higher VE. I'm going to highlight that. Therefore, the null hypothesis is accepted. Null hypothesis simply meaning a statistical way of saying there was not a difference in these parameters between conditions. But now I know what their main observation was. Now this is interesting. Their physiological responses that they measured were not different when they were cycling with or without vibration. All right, this is sounding like something I'm going to want to know a little bit more about. But I'm not going to read the entire paper yet. I'm going to go down. What I would typically do at this point also is look at some of their figures, make sure I understand what they're illustrating. So they have VO2 in mLs per kg per minute versus power. This is a cycling test, so this is very typical to put power down here, which would equate to intensity. 284 watts is a big amount of watts. And then they've got 2 data sets, cycling with vibration and cycling without vibration. And now I can see that those VO2 data points are pretty identical. Maybe something's going on here, but in essence, these two lines are hard to distinguish from each other. This looks like blood lactate. It's interesting they didn't mention that before, but this would be anaerobic byproduct. So this is also why they're measuring VCO2, because lactate will be buffered, and then you'll have an increase in VCO2. But in any case, they've sort of surprised me here and have lactate. Nevertheless, they have power down here again. They've got blood lactate amount, vibration, no vibration. Pretty similar data sets, maybe something going on around 188 watts, but overall, not much of a difference between these two conditions. So I'm again this is looking interesting. I'm going to want to know more, but I'm going to jump down to the conclusion. Now again, that's going to be related to their main observation. They repeat the purpose statement, but I'm looking for the concluding statement. Okay, again, I haven't read this, so I'm just looking for where to start here. Although this study is highlighted vibration through analysis of the data, adding vibration stimulus to cycling did not significantly affect the cardiovascular and metabolic responses compared to normal cycling. Right? Sometimes at this point, you can also find what they think needs to happen in the future. So down here, even a lot of times they'll add a statement like this: further investigation should deepen the various physiological and neuromuscular incurred with vibration, is what the implication here is. All right, so now I've confirmed their conclusion matches their main observation. I've looked at their data and the figures, and now I want to know more about this study. And I'm actually really curious as to how they induced vibration, because now I'm wondering what type of vibration the person was experiencing. Were they vibrating the wheel? Were they vibrating the handlebars? Were they vibrating the seat post? Now I'm curious, because that vibration, how they delivered it, may actually explain the outcome of the study. So now what I would probably do, I won't do this in this video, is I would go in and start looking at some of the methods. Okay, and I would look specifically at how they were delivering the vibrations. And that's somewhere within this, here's vibration, could be activated or deactivated with a small command, located at the bike's handlebar, the crank. Okay, I might as well just find it now. We're talking about gearing. These variables were just, you're doing this in real time, so this vibration was transmitted from the bike crank to the pedals and then to the lower limbs. So there's their vibration. Interesting. So they vibrated the cranks in the pedal, and then that vibration was sensed by the lower limbs. So this is not vibration at the handlebars. Okay. So now that's really interesting, because if you're biking, it's interesting to think about where you're sensing the vibration is coming from. Are you sensing it coming from your hands, your feet, your seat? It's one of those 3 points. So this is specific to delivering vibration down at the pedals. So if I do this experiment again, and maybe I induce vibration at the fork, the front wheel, which would be sensed by the hands, maybe something's different. I don't know. But now I know a little bit more about the methods. Now I'm really interested in this study. So now what I'm going to do is go back up, and I'm going to start reading the manuscript from the introduction. Then I'll go through the materials and methods. Now I'm going to read it in order. Then I'm going to read their stat analysis, how they objectively compared their data. And then I'm going to look at the results. I'm going to focus in on their figures, make sure I understand the data that are being presented. And then that will take me down to the discussion section. I'm going to look at how they critically evaluated the results. I'm going to make sure that they've compared their data to other studies, that the data seem reasonable. I'm going to look for confounding factors that they considered. I'm going to look for limitations that they may have considered. And then I'm going to look for where they really interpret the meaningfulness of the data. That's all going to be in this discussion section. And then at that point, I'll decide whether or not I'm going to include it as one of my papers that I'll emphasize in in your case, in the semester project. And if I do emphasize the paper, obviously you can't spend that much time on all 4 papers. So you're going to have to pick some information to highlight. Maybe I want to highlight some of the graphs like this. All right. And I can briefly describe that this study compared VO2 with and without vibration during a graded exercise test, and the amount of vibration did not influence VO2 and that vibration being delivered to the feet. That's a real simple way to include something like this in a semester project presentation where you can emphasize an empirically based data set. All right, so that's how I go through reading a paper. Again, in order for me to include the citation in any work that I do, any publication, presentation, or talking about it, I will have had to have read the paper from start to finish. But before I do read the entire paper, I go through and I look for some of those important pieces to decide whether or not I want to read the entire paper. And that way I can be a little bit more efficient, maybe move on. If this paper is not providing information that I'm interested in, and maybe it's not related to my project, maybe, you know, I get going and maybe it's not cycling, but maybe it's, you know, some animal research that involves a different type of use of the word cycling, turnover or something like that. Okay, so I hope that helps, and I hope that helps you as you are looking for papers. And these are great tools to use to pull out objective information and conclusions that is based upon experiment and following the scientific method. Okay, thanks everybody.